In example 5, they're wanting us to evaluate this integral using the fundamental theorem of calculus part 2. And what that says is we're going to find the antiderivative of e to the x, and then we're going to plug in our upper limit of integration and our lower limit of integration and find the difference. So first, when you do the antiderivative of e to the x dx, you just get e to the x. And then we're going to evaluate that from 1 to 3. And this is the little symbol that they use after you've done your antiderivative and you're filling it in. Now here, we're not putting plus c when we do these problems, so you don't have to worry about the constant for this type of problem when they give you the numbers to plug in. So now we're going to plug in 3, we get e cubed, minus, then we plug in the lower limit, e to the first. We're subtracting those, and that is as far as you can go for that one without a calculator. Example 6, they want the area under the curve from 0 to 1. And you need to remember that area is the same thing as doing your integration. So we're going to go our lower limit to our upper limit on the integration sign, and then you put your equation, which is x squared, and we're going to do the antiderivative with respect to x. So here we get, if I raise the exponent, it'd be x cubed. And then if I divide by the 3, I get 1/3. And then, so that's my antiderivative. I don't need to do plus c. And now we're going to evaluate it from 0 to 1. So we plug in 1, and then we plug in 0. And here we get 1 cubed is 1, times 1/3 is 1/3. And then here we get 0. And so we're getting an area of 1/3 for that. In example 7, they want us to evaluate the integration from 3 to 6 for x, dx over x. If you don't recognize what this is, they're just writing it in a weird way. You should probably start by writing it as this, 1 over x times dx, and then do your antiderivative. And we see that this is the derivative of natural log. So when you do your antiderivative, it will be natural log absolute value x. And then we're going to evaluate that from 3 to 6. So we plug in our upper limit of integration and our lower limit of integration, and we subtract those. Since 6 is positive, you can go ahead and leave it positive, and 3 is positive, so you can leave that positive. When you have a limit minus a limit, then you are dividing them. So ln 6 divided by 3, which is natural log 2. And so that would be the area under that. On example 8, they're asking for the area under the cosine wave from 0 to b, where b is between 0 and pi over 2. So what we're going to do to find the area is find the integration of cosine x from 0 to b. So we would write that as 0 to b cosine x. Since the input variable is x, that's what we're doing the antiderivative in respect to. And then the antiderivative of cosine is sine. And then we're going to evaluate it from 0 to b. So if I plug in the upper limit of integration, I get sine b. And then subtract, plugging in the lower limit of integration. And then sine of 0 is 0. So we're getting sine b minus 0. So we get sine b. And so that would be the first part that they wanted us to do. And then just in case b is pi over 2, we could say if b is pi over 2, then we can actually get a real answer here. And so that would be, it'd be sine pi over 2, which is 1. In example 9, it asks, what is wrong with the following calculation? So we've got 1 over x squared dx, and so we look at what they're doing here. They've changed x squared into x to the negative second, and then they've added 1 to the exponent, so that's why it's x to the negative first. They then divided by -1. They then evaluated it from the upper limit to the lower limit. So we see that they're plugging in 3. And since it's -1 on the bottom, there's a negative in front. And since there is a negative in the exponent, that when you plug in 3, it becomes 1/3. They've also plugged in -1. So you plug in -1 here. The negative on the bottom turns it negative, and then the negative on top just flips the 1 to the bottom. So 1 over 1 is 1. And then they've subtracted these. They got a common denominator and got -4/3. And so we're left wondering what did go wrong, because it looks like everything worked out and it looks like they did it right. But when we go back to our fundamental theorem of calculus, it says suppose that the function is continuous on a to b. So this theorem only works, we can only do the integration and plug in b and a if the function is continuous on the interval. And if we look at the interval they gave us, -1 to 3, this function is undefined at 0, and 0 is between -1 and 3. So this function is not continuous, and that is why this calculation is not correct.